So Taylor hits a golf ball at an angle of 25 degrees to the ground with an initial velocity of 89 meters per second. Draw a diagram showing the object's projectile motion. What are the x and y components of the golf ball right after leaving the ground? And how long will it take the ball to reach the maximum height? How far will it travel in the x direction before hitting the ground? So these are all things you should be able to do. On the final, you probably won't be asked to do all of them, but you should be able, or at least not in a row. So like, it's not going to be, you know, here's all the things, and then your answer choices are like 4 answer things with random things. So like, there'll be one problem where like you guys solve for B, and one problem where you'd have to do C, and one problem where you have to do D. So they'd be separate from each other. But you should be able to do all of those parts. Okay, so the first thing we need to do, I'm going to do here so we have enough space. First thing you're going to need to do is draw the diagram. So you've got Taylor hitting the golf ball. Okay, so 25-degree angle. Resultant velocity of 89. It's going to travel a curved path. So that's what the diagram looks like. Something like that. And then the thing you want to do after that is you want to make your X and Y T-chart. Now, we haven't done this in a while. But what you're doing here is you're writing down what are the things in the X direction that we know and what are the things in the Y direction that we know. So keep in mind the forward motion is constant. Gravity does not act side to side. Gravity only acts up and down. Okay? So in the X direction, it's going to be constant motion. So the values you're worried about in the X direction are velocity, displacement, and time. You don't have to worry about acceleration because it doesn't accelerate side to side, and you don't have to worry about initial and final velocity because that only works if there is an acceleration. In the Y direction, it's affected by gravity, so there is an acceleration in the Y direction. So in the Y direction, you got to worry about A, VI, VF, and then also displacement and time. That'll be true of all these problems. So for all these 2D motion problems, it'll be those 3 things for the X direction and those 5 things for the Y direction. It'll never be switched around. It'll never be the same. If you get confused, you can do this same thing for the X column, and you just make A 0, and VI and VF would be the same number. Okay, so that would work too. But I think it's helpful to think about it this way, to separate the 2 sides, keep track of those. So what I want you to do is I want you to take a minute here. I want you to try to get started. So the first thing you should do is fill out the X and Y chart as much as you can. And then once you've done that, I want you to start on B. B wants you to find the X and the Y components. If you get done with B before we talk about it, go on to C. And if you get done with C before we talk about it, go on to D. And then if you're done and waiting for us, then go ahead and just keep working on the review guide. If you need to check answers, you can check answers. Otherwise, just kind of keep working through the problems or the concepts. Again, the more that you do, the more bonus points you get, and it's going to help you a lot on the final. So just keep that in mind. So go ahead and work here. I'll come around in a couple minutes and start checking and see if you have any questions. Okay. As soon as I see the words, what are the X and Y components? The instant I see that, I'm saying to myself, self, that's a triangle. As soon as I see X and Y components, I'm thinking B, A. The A part of the triangle, the B part of the triangle. That's the X part, Y part. As soon as I see that, that's what I'm thinking. So then I look and say, okay, well, how do I find A and B? So I'm looking at my vector equations, okay, because these are vectors. So I'm looking at those equations, and I'm saying to myself, okay, I need to find A. How do I find A? Well, Pythagorean theorem's got A in it, but it's also got B and C. Now, I know what C is. C is the 89, but I don't know what B is, so this isn't going to work. So now I go on to B. I'm not looking for a B yet. Here's A. A equals C cosine theta. I know theta, that's the angle. I know C, that's the resultant vector, and I'm solving for A. So that's where I'm going to start here with this. Okay, so A equals C cos theta. That'll be 89 cosine of 25. Then I plug it in. And I get 80.7. And these are meters per second here. Okay, so I've got A. Now I'm going to do B. So if I go back to my equation sheet, I went across that B equation, came across that B equation. So that's the one I'm going to use here. So B equals C sine theta. 89 times sine of 25. Now, I always get asked, can't I use the Pythagorean theorem here? Yes, you can. Okay, you can use the Pythagorean theorem here. The reason I suggest not using it is I think it's helpful to use each equation as its own thing. Okay, I think it's helpful to only use Pythagorean theorem to find C, to only use this to find B, to only use cosine to find A, and to only use tangent to find theta. That way you know exactly what it is you're solving for, and it allows you to kind of simplify things. Yeah?
How did you get 80.7?
Here. 89 cosine 25.
I got 80. I got 80.1. So I did the cosine 25 first, and then
It should be fine. Like if you got 80.1 as an answer for a multiple choice thing, this like it's not like you're getting like 80.6, 80.1, 79.7. Like they should be significantly different enough that you would be able to tell. Okay, 80.7, 80.1. Those are pretty similar. It's just a rounding thing. Okay, as I go, I like to fill out the chart as I'm doing things. So once I found these A and B values, I can start filling out the chart from here. So here was my triangle. So A was 80.7, B was 37.6, C was given, it was 89, and theta was the angle 25 degrees. Okay? So there's my triangle. So I'm looking at my triangle and I'm saying, what of those things can go into the X and Y chart? And C is at an angle, so C doesn't go X or Y. It's a combination of X and Y. So C doesn't go in here anywhere. Theta is an angle, again, combination of X and Y, so it doesn't go anywhere. But 80.7 is the X velocity. So that would go in here, 80.7, because that's how fast it's going forward. And then in the Y direction, the 37.6, that would be how fast it's going upward. Okay, so now I'm looking around, I'm saying, are there any of these other things that I can figure out? Well, I don't know how far it's going forward, so that's out of the question. I don't know how long it takes, so that's out of the question. Acceleration. I do know what the acceleration is. The reason why this is accelerating in the Y direction is gravity. And gravity is 9.8 down. So it looks like I'm setting positive to be up. This is a positive number. And I can go ahead and just confirm that here to myself. Positive is up. Well, that means acceleration of gravity is a negative 9.8. I don't know anything about the final velocity yet because I don't really know where it's talking about. I don't know anything about the vertical displacement, so like how high is it from here to there? I don't know that. And again, I don't know how long it's going to take. So that should give me everything set up for B. So now I look at C. How long will it take to reach the max height? So I'm working on C now. And it asks how long will it take to reach the maximum height? So right here is what I'm looking for. I'm looking for part C right there. I want to know how long does it take to reach the maximum height. So I'm solving for time, how long it takes to do things, that's time. I've got two t's. I've got t in the y column. I've got t in the x column. What you need to do is figure out which column do you want to use to solve for it. Do you want to use the y direction to solve, or do you want to use the x direction to solve? Look at what you're given. Look what you know. See if you can figure out. I'll give you a hint. You're going to have to assume something. There's something you're going to have to assume. So read C carefully. See if you can use that to figure out what else do I know. You're going to either need to know D in the X, VF in the Y, or D in the Y. So make sure you can see if you can figure out which of those things do you also know based off the wording. Okay, give you a couple minutes here. So C, want to know how long it's going to take to reach the maximum height. So you got to make one big assumption, and it's based off of the maximum height. So the maximum height is halfway through its motion. That doesn't tell me anything about D, because I don't know what the total motion is. So that's not going to help me for D. In the y direction, though, V final is going to be here. So we're looking for the final velocity at the maximum height. And in the y direction, that is a very specific number. Up and down, at the highest point, the velocity final is 0. And the reason it's 0 is because at that point, it hasn't started falling yet, but it's not going up anymore either. Okay? And that's the big key. The big key is figuring out that the final velocity at the maximum height is 0. Again, it hasn't started going down yet, but it's not going up anymore. So now I'm looking for an equation that's got A, VI, VF, and T. The equation that has those things is Old Faithful. Okay, so VF is 0. VI is 37.6. Notice I'm using this number. I'm not using this one. I'm not using the 89. I'm using this 37.6. Plus A, which is negative 9.8, times T. So to get this, I'm going to subtract 37.6 to both sides. That gives me negative 37.6 equals negative 9.8t. I'm going to divide the negative 9.8 to both sides. And that gives me a time of 3.8 seconds. Okay, and that should take care of C. So now I know how long it takes. Okay, it takes 3.8. So now I figured out the time. All right, on to the last part. D wants to know how far it will travel in the x direction before hitting the ground. So I'm looking for how far forward will it go. So I'm solving for D in part D. That's not confusing here. So I'm solving for D in part D. Okay, so I want you to try this one out. See if you can find the displacement. Be careful. We've got two displacements here. We've got a y displacement. We've got an x displacement. Make sure you know which one you're solving for. Okay, so take a minute here. See if you can figure out which one to solve for. So for D, I want to know the time. So I was given the time that I just solved for here, 3.8. Okay? I'm asking for the forward displacement. So I'm not solving for D in the y direction. Okay, so you don't need that. What I'm looking for is D in the x direction. But here's where we have to be careful. The 3.8 seconds, remember, time goes in both directions. So this time goes over here. But this time is to get to the max height. And I want the time to get forward the whole way. Well, the max height is going to be halfway through the motion. Always for the kind of problems you're going to be given. So if I'm looking for the displacement whole through the motion, but I was given the time for halfway, then I need to double this time. So that's going to be 7.6 for the time. Now I'm solving for the x direction. I look at my x equations. Well, the x direction is constant, so the equation I'm going to use there is v equals d over t. Okay, I'm using the x velocity. I'm not using the y. I'm not using the 89. I'm using the 80.7. And that gives me displacement that I'm solving for over time, 7.6. Multiply 7.6 to both directions. And I get a displacement of 613 meters. Okay. So that's what you want to be careful on these. Again, the biggest part of 28 is figuring out what to solve for and figuring out what you're given. Yeah.
Is the test going to round to the hundreds place? Because I rounded to the hundreds place.
Yeah.
And my number was 60.
Again, you're most likely going to have the numbers be far enough apart that that should not become a big issue. So, like, it's not like you would get, like, 613, 615, 611. Like, you would get, like, 613 and, like, 570 and, like, 1,010. Because, like, a lot of times the answer choices are based off of, like, mistakes that you might make. So, for example, like, if this was what I was solving for, one of the answer choices would be forgetting to double the time. So instead of 7.6, if you use 3.8, like, that answer choice would be on there. Another one would be, like, instead of using the 80.7, it would be the 90 or the 89. So, like, they should be different enough that you're not going to have that come up. All right. Good.